Hi, it's David here in ISR3 with 4590 GreenBlitz. GreenBlitz has a wonderful season so far, and today we'll talk about their amazing robot. They're a multi-gripper that can do both coral and algae. They can do coral on L3, L2, L3, and L4. They can do a climb very fast and everything more on behind the bumpers.
Okay, so we have our end effector that picks up both algae and corals. To be legal in the trade parameter, we have these flaps that help us intake the coral that get bent over by the steel wire, and then by the pin that is attached to the chassis by a spring. When we open it up, it disconnects the pin, and then the flaps come out. So we can pick up both algae and coral. Intake, please. Okay, so we have our flaps. Previously we had a shorter flaps that didn't need to get bent over, but after we added those, it started very consistently every time picking up the coral. Pick up algae. We use the same wheel to pick up both algae and coral in this way.
Okay, so this is our elevator and also our mechanism. We wanted those two to be as rigid as possible, so we can see that this axle is a dead axis, and when we wanted to do it, we had to find a better solution for the can coder that we wanted to place there. If you look here, there is a can coder right here that we can use to find the placement of the arm. And what is interesting about this placement is that it's a virtual forebar that we use to put the can coder outside of the arm. In the elevator, we use counterweights. To ensure the elevator can open and close as fast as possible. And also, the elevator is built in such a way that allows us to close it faster than gravity. This is the reason we have two sides to the elevator. Okay, so the gearbox is the elevator is controlled by two krakens at the bottom, and is reset by this here limit switch. When we want to start the match, when we want to start the match, we press it in and we know where we are.
So finishing off with our climb, we have the ratchet assembly that is entirely custom made. It's also solenoid actuated. It starts on from the planetary gearbox, goes on to a custom gear ratio, and this is solenoid actuated. This opens that way with the solenoid, and we can reclose it, and it's ratcheting, because the solenoid is mounted on a spring, it's ratcheting the other way around. And talking about a latch assembly, we have these two. We have this latch. It's a standard Everbot latch. You just have two rotation points instead of one. It doesn't really matter. And what we do with the climb, one side pulls, one side pushes. It just clamps onto the cage. And the last thing about the climb is that we have these little flaps that protect the end effector from latching onto our climb when we start the game. And finishing with our chassis, we have nothing important, really, nothing too special, except the bumpers, which actually have swerve guards on them. The swerve guards are mounted on the bumpers.
So, some cool stuffs in our programming is and our control system. I start with our vision system. We have a Limelight 3 that we switch the sensor in it to have a global shutter instead of a rolling shutter. This helped us to improve our vision and to get a better knowledge of where we are. We can also see it here on the Limelight that is pointing to the feeder. Yes. Another cool thing that we did in our programming is we have a code component that we call the heading estimator. What it's doing is taking the measurements from our limelights and from our gyro in the beginning of the match, and it's using a Kalman filter to fuse them, and from that we know what's the angle of the robot will start the match. With this knowledge and with our pose estimator, we're doing the start of the autonomous from wherever we want on the field. We can start our auto from anywhere in the auto line, and it will go to the chosen branch with a generated path. This allows us to place the robot anywhere that we want, at any orientation, as long as you can see at least an April tag. Another cool thing in our robot is the dynamic limit of our accelerations of the mechanisms. As you saw when we ran the robot before, we grip our algae from here and we move the arm all the way to the other side. When we did it in Israel District 2, the algae fell a lot of times because the high acceleration of the arm. What we did is between the districts we added another carnivore and we used dynamic motion magic on our elevator and our arm. This let us to change the max acceleration and cruise velocity of the mechanisms, and we also use it with our state machine, and for each state of the robot we have a different acceleration for it, which lets us to rotate the arm slowly when we have an algae, but very fast when we want to score a coral.
Thank you so much, GreenBlitz 4590 from GSA Academy in Dakfar, Iraq. I wish you the best of luck for the rest of the season and see you soon.